All right, guys, we're going to continue to talk about functions. Today we're going to talk about function notation. So what is function notation? Equations that represent functions. Okay, remember we talked about functions before. Equations that represent functions are often written in function notation. So this is just a different way to write the same thing. So if we have y equals 4x minus 1, that can be written as f of x, which is the same as y. F of x equals 4x minus 1. So when we input an x value, f of x is our output, or our y value. This is read f of x equals, whatever the equation is, f of x is the output, or your y's, and x is the input. All right, look here to see an example. Function notation is especially useful for finding a value in the range, okay, your y's, that correspond to a certain domain, which is your x. All right, so example, if f of x equals negative 4 minus 1, find f of negative 7. So we're going to take negative 7, f of x, we're going to plug that in for x, and on the left side is just kind of the name of the function. So we leave that there. That's our output when we find the answer. So we don't have to really do anything on the left-hand side except just leave that so we know what we input into the equation. So negative 7 times 4 is negative 28. Negative 28 minus 1 is negative 29. So we input negative 7, or x, and our output, or our y, is negative 29. So if you graph this line, you would find this ordered pair on that line. All right, here's some examples, guys. Evaluate each function for the given value. So again, this is very similar to what we've done. Okay, we've had a table of values with x's, or inputs, and we've plugged it into y. The only difference is now this is in function notation. So f of x, 5 is our x, so we're going to plug that in. So we're going to say f of 5, that's the name of our function. F of 5 equals 5 plus 7. So 5 plus 7 is 12. That is our output, or f of x equals 12. So 5 would be our x, 12 would be our y. 5 would be the input, 12 is the output. Okay, again, this ordered pair, if graphed this equation, this ordered pair would be on that graph. All right, so g of negative 3, that's the same as g of x is the same as f of x or h of x or whatever. Again, that's just function notation. It's just another way to write an equation and represents that it is a function. All right, so g of negative 3. So we're going to take 3 times negative 3 minus 8. 3 times negative 3 is negative 9 minus 8, negative 17. All right, so our output, or g of x, equals negative 17 when you input negative 3. All right, h of x equals 2/3 times, this time h of 9, minus 1. So all I'm doing is taking this 9 and I'm putting it in for x. All right, so if we do 2/3 of 9, that's 6 minus 1. 6 minus 1 is 5. Here we have a squared term. We're still going to do the same thing. So we're going to take negative 4. We're going to substitute it for x. This time there are 2 x's, so we do have to substitute it in both places. So we're going to say f of negative 4 equals negative 4 squared. Make sure you use parentheses so you don't lose that sign. And negative is part of the equation, but x is also negative. All right, negative 4 squared, anything squared is positive, so that's going to be 16. Negative times a negative is positive, so that is also positive 4. 16 plus 4 is 20. So when x is negative 4, y is 20, or f of x. All right, a little bit longer equation here. Going to do the exact same thing. We're going to substitute a 5 in the equation. So that's going to be our x. F of 5 equals negative. X is 5, so we're only going to put 5 in for x. This time the negative was already there. That's why it's on the outside of the parentheses. Plus 6 times 5. X goes away, and we input 5 again, and then minus 4. All right, this time negative is already there, so keep it. 5 squared is 25, and plus 30, and minus 4. So this time, f of 5, negative 25, plus 30 is positive 5. 5 minus 4 is 1. So when you input 5, you get 1 as your y value. All right, guys, I got tired of stuff popping up on the screen, so I'll move this up a little bit. I hope that's okay. All right, so this time our x, or our input value, is negative 8. So we are going to do the same thing. We've got g of x equals negative 1/2 as part of the equation. And we're going to input negative 8, and then we're going to add 9. So two negatives when you multiply as a positive, and half of 8 is 4 plus 9. So when I input, I forgot to input my negative 8 here. All right, so when I input negative 8, I get 13 out. All right, number 7, f of, this time we're going to substitute negative 5. All right, so again, I took the negative 5 and I plugged it in for each place there is an x. All right, so when you look at it down here, I put negative 5 here and squared it, and then negative here. All right, if you remember, order of operations always applies. So I do exponents first. Negative 5 squared is 25. And then I can go ahead and multiply. 4 times negative 5 is negative 20. Bring down my negative 9. Now I multiply after I did my powers. So 2 times 25 is 50. 50 minus 20 and negative 9. I can go ahead and combine those if I want. And then 50 minus 29 is 21. All right, number 8 is an absolute value, but it's still going to work the same way. I'm going to input my x into both places here. All right, if you remember, absolute value is going to be evaluated at the end. So I have to evaluate everything on the inside and then take the absolute value. So I'm going to do g of negative 7. And I'm going to have the absolute value of negative 7. And then minus as part of the equation. And I'm going to have negative 7 squared. All right, so again, we're going to do inside first. So evaluate inside out. All right, so we're going to leave the negative 7. We got to do exponents first. So leave this negative here. We're not messing with it yet. Negative 7 squared is positive 49. And then negative 7 minus 49 is negative 56. And now the last thing is, what is the absolute value mean? Absolute value means distance from 0. So when you take the absolute value, you're going to get a positive number as long as there's not a negative on the outside. So in this case, the absolute value of negative 56, the negative's on the inside, the absolute value means distance from 0 is 56. All right, number 9 and 10 are just a little bit different. It's because you're going to input an expression, which means it still has a variable, into the equation. So we're still going to input what's given, f of x, or in this case c plus 7, in place of x. So it looks a little different, but it's going to work the same. So we're going to input c plus 7, so we're going to have f of c plus 7 equals 4, and in place of x, we're going to put c plus 7 and then plus 11. Now you have to evaluate. All right, we still have a variable, so we can't get rid of everything and just get a number like we did before, but we can still simplify this. So I'm going to go ahead and rewrite that. Again, I apologize for my handwriting on the computer. All right, so the first thing we're going to do is distribute. So you got 4 times c, and you have 4 times 7. And then bring down the plus 11, and then combine like terms. So we don't have anything to combine the 4c with, so it comes down. And 28 plus 11 becomes 39. So when you input c plus 7 into your function, you get 4c plus 39 out. So that would be your output. All right, on this side, we're going to substitute 2k plus 5. So h is our function this time. H of 2k minus 5 is equal to negative 9 minus x. And in place of x, we're going to put 2k minus 5. All right, so again, we're going to simplify, bring down the negative 9. This time we got to distribute the negative, so negative 2k, and negative times negative 5 is plus 5. I don't have anything to combine the negative 2k with, but negative 9 plus 5 become negative 4. Input this, output this. All right, for 11 through 16, this gives you 3 functions, f, g, and h. So you're going to choose the function you need. In this case, we're going to do function f, which is only the first one. In this one, we're going to do g, which is the second one. The third one, we've got g plus g, so that one is the middle one. And then h and f. So h and f will be used for the last one. So let's look at f of 4. So we're going to take f of 4. So we're going to substitute 4 in here. 8 minus 3x. And then we're going to add 9 because that's here. So we're going to have negative 3x. And 8 plus 9 is 17. Never mind, I forgot to plug in the x. Oh, let me back up here for a second. Okay. All right, guys, so I went ahead and erased this and substituted the 4 in, and I went ahead and completed these because I'm running out of time for my videos. So f of 4, take the function over here and substitute 4 to get your output of 5. Number 12, you're going to do negative 2 times g of negative 5. This is in orange because g is over here. And then g of 4 plus g of negative 1 I'm going to use two functions